Okay, so we have a few more things to talk about. So we have already been using the power rule, but just to put it in words, this is theorem 314 from your textbook, and it's called, let me see if I can make that a little bit better. Power rule or rational exponents. Okay, so essentially what you're going to do is you're going to use the typical power rule where you bring the exponent down to the coefficient in the front, and then you're going to subtract 1. So I'm going to write out the math portion of it, and then we're going to do an example. So the PQ fraction is going to come down in front, and then you're going to subtract 1 from the exponent. Okay, so it's not any different from what we've been doing. Try to focus this one more time because it's a little bit more blurry. Okay, yeah, that's a little bit better. I can just get the angle right. Okay. All right, so let's go ahead and do an example. So y equals the square root of x. This is still a little bit more blurry than I would like. Okay. All right, so first I'm going to convert this to be y equals x to the 1/2. All right, and so we've been doing a lot with implicit differentiation, so we're going to go ahead and do that for this one. We're going to do dy dx is going to equal 1/2 x to the negative 1/2, and it's negative 1/2 because I'm doing 1/2 subtract 1. And so then I'm just going to simplify. Dy dx is going to equal 1/2, and then this negative 1/2 is going to drop down, and I'm going to turn it back to a square root. Okay. Let me give you another example. We'll do a little bit more tricky of an example. Okay, let's see. So let's do it wouldn't be any fun if we didn't have to do the chain rule too. Okay. I really wish this would focus better. Actually, give me 1 second. I'm going to try to. This. And I want to see if I can switch this guy. Let's see what that turned it to. Is that what I want to do? Okay, no, it's not. All right. That's okay. Actually, I'm going to turn this way, and I'm going to turn this guy this way. I'm like, stop doing it. Can't help it. There. All right, that's a little bit better. You're like, just stop moving the camera. I can't help it. Okay. So we're going to say that u is going to be x to the 6th plus 3x. The derivative of u is going to be 6x to the 5th plus 3. And then we're going to say that u is to the 2/3. So that means I'm going to have 2/3 u, and I'm going to do 2/3 minus 1. So if you think about that, 2/3 minus 1, 1 is essentially 3/3, so 2/3 minus 1 is going to be -1/3. All right, so then remember, for the chain rule, what we're going to do is we're going to do 2/3 u to the -1/3 times du, 6x to the 5th plus 3. All right, so let's plug back in our u. So u was x to the 6th plus 3x to the -1/3, and 6x to the 5th plus 3. And so I am going to distribute my 2/3 to the 6x plus 3. Let's just simplify this out. So 6 times 2 is 12, divided by 3 is 4. So we're going to get 4x to the 5th. 2 times 3 is 6, divided by 3 is 2. Plus 2. Wrote that in the wrong spot. Oh, sorry. Oopsies. And that's going to be at the top. And at the bottom, I'm going to have x to the 6th plus 3x to the 1/3 power. Okay, so by dropping that down, I'm going to turn it from a negative to a positive, and that's going to be my final answer. All right, let's do one more. Let's see. Calculate dy dx. Y equals x to the 3/2 plus x. All right, so hopefully you're seeing here that we're going to have to do the product rule. Yay! Okay, so if you think about your two pieces, we've got x to the 3/2, and the derivative of that is going to be 3/2x to the 3/2 power minus 1, which 1 is essentially 2/2. Okay, so 3/2 minus 2/2 is going to be to the 1/2. So 3/2x to the 1/2. And then the derivative of cosine, remember, is negative sine x. Okay, so let's go ahead and write out our product rule now. So we're going to do dy dx is going to equal normal x times the derivative of the cosine plus derivative of my x, 3/2x to the 1/2 times normal cosine. All right, and then we can just clean this up a little bit. So negative x to the 3/2 power times sine x. And this one is going to stay the same. You could, if you wanted to, put x under the square root, but you can just leave it like that for this one. So dy dx equals that. Okay, we're going to add one final piece, and then we're finally done with 3.7. So do you remember when we were doing tangent lines? Yeah, I know, we've been doing it for so long. So we're going to add that on with this. So the process is the same. Okay, so find the slope at 0.442 y equals 2x plus y to the 1/3 power. Okay, so hopefully you're noticing that we're going to have to use the power rule and the chain rule for this guy. So I'm going to call u x plus y. And so then when I find the derivative of u, the derivative of x is just 1, and the derivative of y is dy dx. Okay, so then we have 2u to the 1/3 power. Okay, so I need to take the derivative of that. So 2u to the 1/3 power, I'm going to do 1/3 times 2. So 2/3 u, and then I have to do 1/3 minus 1. So 1/3 minus 1 is going to give me negative 2/3. Okay. All right, so essentially I'm going to have to do 2/3 u to the negative 2/3 times u prime. So let's substitute everything back in. X plus y to the negative 2/3 times u, which is 1 plus dy dx, and that is equal to dy dx. And why is that equal to dy dx from this y? Okay. Oh, that's really blurry. Still a little bit blurry. It's not horrible, but it's not the best. Okay, so just like we were doing before, we're going to end up having to distribute, okay, because this whole thing was my u prime. So we're going to end up distributing the 2/3 x plus y to the negative 2/3 to 1 and to dy dx. So essentially we're going to get the same thing. Because we're timesing it by 1 and then timesing it also by dy dx. Okay. So then what we have to do is we have to get our dy dx's the same side. Okay. So I'm going to move this one over. So I'm going to do minus 2/3 x plus y to the 2/3 dy dx. And the same thing over here. I'm not going to write it down because I'm running out of room on that side. So I'm just going to give myself some more space. So 2/3 x plus y to the negative 2/3 equals dy dx from my original minus 2/3 x plus y to the 2/3 dy dx. So then what we're going to do is we're going to factor out the dy dx. So I'm going to get 1 minus this whole thing. And then we just simply need to divide. Oops. Got a little excited with my parentheses. All right. So total, we're getting this pretty nasty thing. 2/3 x plus y to the negative 2/3, 1 minus 2/3. Okay, so I'm not sure about you, but I really dislike negatives. And so I would really like it if we didn't have to have so many negatives going on here. So what we can do is we can actually multiply the left side by 3x plus y to the positive 2/3. Okay, so if I do that, that's going to make this part times this part. If we have a positive 2/3 and a negative 2/3, it's going to give me 0, and anything to the 0 power is 1. And then 3 times 2/3 is just going to leave me with 2 at the top. And then at the bottom, we're going to have this times the 1. So 3x plus y to the positive 2/3. And then the same sort of thing is going to happen here at the bottom. The negative 2/3 and the positive 2/3, when you add them together, you get 1, and anything to the 0, anything raised, or I'm sorry, you don't get 1, you get 0, and then anything raised to the 0 power gets, so you get 1. So then you're just going to be left with 3 times negative 2/3, which is going to be negative 2. All right, so the very last step is we're going to plug in our point. Our point was 4, 4. So 2/3 times 4 plus 4 to the 2/3 minus 2. And if you do that, you will end up with 2/10, which is reduced down to 1/5. Okay. All right, so there's one more example. So I'm going to write this example down, and then I actually want you to try it. And then I want you to check online for my notes and see if you got it correct. Okay, so I want you to try this one. Same thing we just did. Same thing we've been doing. Okay, so I want you to go ahead and find the slope of xy to the 5/2 plus x to the 3/2y equals 12 at 0.41. Okay, and then I want you to check, I've uploaded a scanned document with all of my notes from the videos. So I want you to check that to see if you got it right, and let me know if you didn't. Okay.